In this lesson, we're going to consider a macroeconomic model. I like to call it the spending allocation model, or SAM. It really tries to describe some of the concepts we've been describing already in terms of the data, gross domestic products, total consumption, total investment, net exports, and government purchases. So the way it works is it's a specific thing that focuses on those entities: consumption, investment, net exports, and government purchases. And it's a model. We're going to call it a macroeconomic model because it pertains to these macroeconomic concepts. And it's going to be used to determine the shares of spending in GDP by these different concepts, whether consumption, investment, etc. There's actually a very close analogy with this macroeconomic model and the supply and demand model of microeconomics. We're going to try to exploit that connection as we learn how to use this first macroeconomic model in this course. The model is really going to be most useful for long-run situations. So like any model, you need to know when to apply it. Just in the microeconomics, some of the models are more relevant for short run, some are more relevant for long run. This is more relevant for the long run, 5, 10 years or so in the overall economy. The starting place is some of the equations we've already derived. When we described how GDP is calculated, we mentioned it could be the sum of consumption, investment, government purchases, and net exports that people spend in the economy, and that adds up to GDP. To make it a little more manageable, if you divide all those entities by GDP, which we call Y, then you convert them to shares of GDP. So for example, you'll have now that consumption divided by GDP plus investment divided by GDP plus government purchases divided by GDP and net exports divided by GDP must all sum to 1, those shares. Sometimes we describe those shares in percentage terms rather than fractions, so we might say consumption is 65% of GDP rather than just say it's 0.65. But it's really clear from this example that if any one component of this sum goes up, the others must go down. So for example, if G over Y, the percentage of government purchases in GDP goes down, the others must go up, at least the sum of them must go up. And our question here, and why we need a model, is we want to describe how that actually happens in the economy. So for example, if government purchases, a share of GDP goes down because of a government effort to reduce spending, reduce total spending in the economy by government, how does that translate to the other parts of the economy, to consumption, investment, and net exports? We also want to think about the mechanism that this occurs. What's the incentive that consumers or businesses might have to adjust their consumption or investment by that much? Or what are the incentives that exporters have to adjust their amount of exports? And then, as in any kind of model of a price system, what transmit this information? There's incentives, and then the information has to be signaled and communicated. And so, in other words, what is the variable that takes the place of the price, which we use in microeconomics, supply and demand for bicycles, for example? In other words, what is the price that we consider? And we will see that the answer to that is the interest rate. The interest rate is actually going to be the price that helps allocate these spending decisions between investment and consumption, net exports, etc. So we need to think about these shares of spending over time. Here's an example of what these shares look like in the U.S. economy during the 1990s. The 90s is a good time to look at this because there were big shifts in shares and the economy was operating pretty well at the same time. So you can see on the upper left, it's consumption as a share of GDP, and you can see that's generally rising. You have investment as a share of GDP, that's generally rising. On the lower left, net exports as a share of GDP, that's declining. And government purchases as a share of GDP, declining substantially. You just look at the trends here, you see the consumption was up by about 2% in that period. You had investment up by about 5%, net exports down by about 4%, and government purchases down by 3%. So the sum of all those percentages is 0, as it must be, but the real question is, how did this occur? How did the economy change with the private sector making decisions about consumption, investment, and net exports? and really the government, the public sector, determining the decisions about government purchases. So that's what the model is going to be used for, to try to explain how these variables relate in the overall economy. We want to start with a description of how the interest rate affects consumption. Remember, the interest rate is going to be the price in this allocation system. And the interest rate is going to affect consumption, investment, and net exports. We want to trace those through as carefully as we can. To get the effect of interest rates on consumption, we want to apply the central idea of economics, which we've applied many times before, and that is that people make purposeful choices with scarce resources. What's the choice when you're considering consumption in the economy? Well, we're not considering consumption of toys versus necklaces or apples versus oranges. We're considering the total amount of consumption that a person or a family might spend on all those things compared with something else. What do you compare consumption with? Well, you compare it with saving, not consuming. The part of your income that is not consumed is saving. And so the choice here, the binary choice, which we always like to get a hold of in economics, is consumption versus saving. Saving is actually future consumption, because what you put away for the future, you can consume later. So you might just wait till next year rather than this year to do your consumption by saving. Well, what that means is the interest rate will affect that decision, because the interest rate, a higher interest rate, will mean if instead of consuming you put your money in a bank for a year and then consume next year, a higher interest rate means you get more from that savings. You put $100 in, you get $105 out if the interest rate is 5%. But if it's 10%, you get $110 back. So that extra high interest rate, say from 5% to 10%, really lowers the price of future consumption. You can get more consumption by putting your money away if the interest rate is 10% than 5%. You get more consumption next period. So it effectively lowers the price of future consumption compared to today's consumption. And as a result, it makes common sense that people would consume less. It's relatively cheaper to consume next period, next year, by putting your money away if the interest rate's higher, and so you consume less today. So the immediate implication is a higher interest rate reduces consumption. And in reverse, the same thing should happen. A lower interest rate effectively raises the price of future consumption. You get less when you save your money and you put it in the bank. And that's compared to today's consumption. So that suggests you consume more today if the interest rate is lower. So this simple reasoning, based on basic economics, suggests there should be a negative relationship between the interest rate and total consumption of people. And then if you add that up for all the people consuming in the economy, add it up, there's got to be a negative relationship between the interest rate and the total amount of consumption. Now, it's important to realize when we think about the interest rate here, so we want to make sure we don't get confused by inflation, because inflation can also affect the price of future consumption compared to today. What economists do to adjust for inflation is they consider the real interest rate, which by definition is the nominal interest rate minus the expected rate of inflation. The nominal interest rate is just what you normally talk about when you go to the bank, see what the interest rate will be, or you read about an interest rate in the newspaper. But to get the real interest rate, you want to subtract out how much prices are expected to rise from now into the future, because that's going to make goods more expensive in the future to compare to today. So you take out that thing that makes things more expensive and you subtract it, that is, you subtract it from the nominal interest rate, and you get the real interest rate. So for example, if the nominal interest rate is 5% and you expect prices to increase by 3%, the real interest rate is just 2%. And that's what's key in this relationship of the interest rate and consumption. There's a picture, simple graph that represents what I just said. On the vertical axis, you have the interest rate, and the horizontal axis, you have consumption as a share of GDP. We've argued it should be negative. This is an example of what that might look like. And you can see we're representing on the horizontal axis these percentages of consumption as a share of GDP. And that's what we're assuming is going down as the interest rate goes up in this case. Now let's consider investment. Actually, we don't have to consider investment very much at all, because we've already discussed this in microeconomics. We argued, for example, that the demand for a truck for a firm or a food truck for a food services firm goes down when the interest rate is higher. The demand for that investment goes down. Remember, we argued in terms of a rental rate, the rental rate on capital goes up, then the demand for capital, the quantity demanded of capital goes down. And the same thing is true with respect to the implicit rental rate, which depends on the interest rate. So you can go back to the lesson and review that, but we already know that firms will invest less when the interest rate is higher based on simple microeconomic considerations. Same is true if you just think about all the firms in the economy, and that's going to generate this negative relationship between investment as a share of GDP and the interest rate. There it is in this picture, just as an example, and you can see on the horizontal axis we have percentages of GDP and examples of the interest rate on the vertical axis. So we've got consumption, we've got investment. What about net exports? That's the third variable we've got to consider and its relationship to the interest rate. This one's more complicated, the relationship between net exports and the interest rate. Remember, net exports is the difference between exports and imports. Exports minus imports equals net exports. To understand how the interest rate affects net exports, you have to consider several different things that occur in an economy when the interest rate changes. There's a lot of things to sort of put in your head and think about this to get the logic right. Each one is pretty straightforward, but when you put them all together, it's a chain of reasoning that you have to be careful and keep track of as you go. There's two basic aspects to this chain of reasoning. One is that the interest rate should affect the exchange rate, and the second is that the exchange rate should affect net exports. And as you can see at the bottom, implication of this will be the interest rate affects net exports. But let's look at the chains in this argument. So first of all, consider what happens if the interest rate changes. People are going to have a choice here about where to invest their money. Again, purposeful choice with scarcity. In this case, the choice will be to hold a dollar bond, say a dollar treasury security, or a Japanese bond, a Japanese denominated security, denominated in Japanese yen, for example. So that's the choice, a bond denominated in US dollars, a bond denominated in Japanese yen. Now consider the interest rate. Well, the higher interest rate on dollar securities, on say US treasuries, that will make dollars more attractive because people want to move their money out of Japan into the United States to get that higher interest rate. So a higher interest rate in the US will make dollars more attractive, and that will put upward pressure on the dollar, make the dollar appreciate. So in this case, you would get a better deal when the dollar rises relative to the yen, in the case of the yen's example. The same thing in the opposite direction. If you have a lower interest rate on US dollar bonds compared to Japanese, then people will want to get out of dollars and move into yen, and that will put downward pressure on the dollar, so the dollar will tend to decline in this case. So that's the mechanism, is this effect of the interest rate on the exchange rate. Now the exchange rate itself affects net exports. In fact, the higher the dollar, the fewer US exports demanded will be, and the more foreign imports demanded there will be. And as a result of that, net exports will fall. Why is that the case? Well, if the dollar is very high, then it's going to be more expensive to buy US goods, and so the demand for US exports from abroad is going to go down. Basically, US cars will become more expensive if, for example, it takes more yen to buy a dollar. Then the dollar price of a car will go up in terms of yen, decrease the quantity demanded of cars and US exports in general. So, and the same is true with imports demanded into the United States from abroad. Foreign imports demanded will in this case go up because it's cheaper at this point to get the Japanese goods with the stronger dollar, the higher dollar, and so net exports fall on that account as well. And then finally, if you just reverse this, same logic says the lower dollar will cause net exports to rise. Because of the lower dollar, there'll be more US exports demanded. Again, the logic is very much the same. US exports will be cheaper. It takes fewer yen to get a dollar, and the same thing will occur in reverse on the imports demanded. So now, combine those two things. Interest rate affects exchange rates affects net exports, therefore interest rate should affect net exports. And just to summarize, if the interest rate rises, the dollar should rise in value, and that should make net exports go down. So higher interest rates, lower net exports, lower interest rates, more net exports. So that's the logic. Again, each part of this chain, you think about the choices people are making between U.S. bonds and Japanese bonds in the first case, depending on the interest rate, how that affects the exchange rate then. And then second, the choice between Japanese cars, American cars, or more generally Japanese exports, American exports, or even more generally foreign imports and exports compared to the United States. And we got this relationship. Now we can also do a picture of this one, and the graph is looking the same as with investment and consumption. On the vertical axis, the interest rate as usual. On the horizontal axis is net exports. If you look at the scale of the horizontal axis, you'll note that there's a 0 in there because it's possible for net exports to be negative. And to be negative is a share of GDP, of course. That when they're negative, then exports is less than imports. There's a trade deficit. When it's a positive, is a trade surplus. Exports, in that case, are greater than imports. And so we have this possibility of plus and minus numbers. But the logic that we just went through, the interest rate affecting net exports in this negative way, holds, and we're illustrating this in this simple picture. Now that's our three relationships. You can put them all together and think about them. In this picture, you have consumption in the upper left, investment as a share of GDP in the upper right, net exports the lower left. And we're going to add these three things together and call it non-government, if you like. Consumption plus investment for net exports are all the parts of spending that are not G, or therefore NG, or non-government. And you can just sum them across, just as you summed up individual demand curves for people in a market for bicycles or toys. Same thing occurs here exactly. In fact, it's sometimes easier to see the summing across if you align these in a row. And that's what's being done here. In this case, we've just aligned the three components of private spending: consumption, investment, and net exports. Align them, same from the previous picture. And now you can imagine just summing across this diagram to get the total, which is non-government purchases as a share of GDP. Again, it's simply the total purchases less what the private sector consumes, and that's the non-government part of that over on the right. Now what we're going to do, given this setup, and again, the setup is based on all these macroeconomic considerations, we're now going to make this model go to work by focusing on the right-hand side. It's like a demand curve. Imagine instead of the price on the vertical axis, you have the interest rate on the vertical axis, and you have the sum of consumption, investment, net exports, NG, being plotted on the horizontal axis as a percentage of GDP. It's downward sloping like a demand curve. And so now we have to think about what the natural way to think it is about supply. We'll get an intersection between the supply and demand curve. We'll get the interest rate and get predictions of the model, as we'll see in the next lesson. Thank you.